For the discussion, it's section 1.1, functions of several variables. So I hope you've already watched the associated lecture videos for this topic. So we will go directly to the problems. First, let us identify and sketch the domain of the function f of xy equals square root of y all over ln of x plus y minus 1. So before I do the sketching of the domain, let us have some mini problems or mini questions as a warm up. So maybe let's start doing some evaluation. So in here, you have the variables, the independent variables x and y. So let us just choose a point on the Cartesian plane, an ordered pair. Maybe let us have the point 1, 0, and let us evaluate 1. Maybe we cannot use 1, 0. So let me use 1, 1. So we want to evaluate f of 1, 1. So every time we write this symbol, there's a correspondence. You have your x here. So as a first coordinate, so the first number that you will see here will correspond to the value or to the variable x, and y here is the second coordinate. So the second number that you will see here, it's the one corresponding to the second number. So f of 1, 1, if we look at this, notice that we substitute x equals 1 and y equals 1. So we will have here square root of 1 over ln of 1 plus 1 minus 1. Now, notice we will end up with 1 over ln of 1. But ln of 1, it's 0. Okay? ln of 1, it's equal to 0. So this will give us 1 over 0, and this does not exist. So clearly, this value, this 0.1, 1, it's not in the domain of your function f of x, y. Okay? Let's have another point. Maybe we want to evaluate the 0.1, 2. Okay? You have 1, 2. Okay? So for this, we'll just have square root of 2 all over ln of 1 plus 2 minus 1. So this is equal to square root of 2 ln of 2. So this shows that since we got a real number here, it means that the 0.1, 2, it's on the domain of the function f. Okay? And there will be infinitely many points. Okay? There will be infinitely many points. So let us try to find a general way in determining the domain of the function f. So if you look at this, you have square root of y. This means that, so let me write this now, the domain. So we have here square root of y. This implies that our y should be greater than or equal to 0. Okay? And then we have ln of x plus y minus 1. This implies that x plus y minus 1, this should be greater than 0. Correct? Furthermore, since this guy here, x plus, this guy here, ln of x plus y minus 1 is on the denominator, we don't want the value of ln itself to be equal to 0. So this will mean that we don't want x plus y minus 1 to be equal to 1. because, well, ln of 1 will give us 0. And since this is a denominator, we don't want that. Just like what happened in here. We used the point 1 comma 1, and it turned out that the ln of the ln value will be equal to 0 at the point 1 comma 1. And therefore, 1 should not be on the domain of the function f. So from here, let us try to sketch. Let us try to sketch the domain of the function f here. So we want this x plus y minus 1. This should be greater than 0, or this means that we have 1 less than x plus y. Okay? And then for this guy here, we'll just manipulate this. We have x plus y minus 1 not equal to 1. This means we don't want x plus y to be equal to 2. Okay? So the sketch will be, so you are on the Cartesian plane, you have two variables. Remember that if you have a function of two variables, the graph or the domain will be lying on your xy plane. So suppose this is our xy plane here. Okay. So we have here your x, this is your y. We want x plus y to be greater than 1. So let us start by sketching x plus y equals 1. So let us look at x plus y equals 1. This is just a line, okay? And when x equals 0, y equals 1. So suppose this is your 1. And then this is negative 1 here. Negative 1 here. And then this is positive 1 for the x coordinate or for the x axis. This is negative 1 for the x-axis. So if x equals 0, y equals 1. For y equals 0, x equals 1. So we have these 2 points. So we have this line here. Okay? But we want this. We want this. X plus y must be greater than 1. Which means that in order to identify the region here, x plus y greater than 1, one way is to get points not lying on the line. So you have points coming from here and you have points coming from here. Okay? And choose any points that will make our calculation easy. For example, let us choose the point 0, 0 here. Okay? At the point 0, 0, we will have 1 less than 0 plus 0, which is equal to 0. And this is not true. So what does this mean? This means that this side here will not be included in the domain of the function f. So it must be this side. Okay? So again, this side here will not be in the domain or will not be part of the domain of the function f. And therefore, we conclude that this side, the other side, the opposite side there, will be part of the domain. So we will take this side. And furthermore, since we have the strict inequality here, the line x plus y equals 1 will not be included in the domain. Okay? So let us have the domain, at least for that part. So we have this line, so it's just dash line here, and then the domain will be this part. Okay? Furthermore, we have this x plus y not equal to 2. X plus y not equal to 2. So let us sketch the line x plus y equals 2. And then since we don't want x plus y to be equal to 2, it means we have to remove that line also from the domain. So we sketch x plus y equals 2. So when x equals 1, when x equals 0, your y will be equal to 2. So maybe it's this part here. Okay. And then when y equals 0, your x equals positive 2. So it will be somewhere on this part here. So first, let me remove the first region that I draw here. So we will have this. And then let us sketch the line x plus y equals 2. So this is, say this is the 2. And then this is the 2 for the x part. And we will have this line. Okay, we will have this line here. And then this is the line x plus y equals 2. But then again, we don't want that. So in the domain, this is just dashed line. Okay. Now, don't forget, your y must be greater than or equal to 0. Your y must be greater than or equal to 0. It means that what? We only take the ones above the x-axis. And therefore, okay, and therefore, the graph or the domain of your function will just be this part here and also this part here. Okay? Question so far? So this is just half plane. Okay? It's just a plane. That's the domain of your function. This is just half plane. And there are some other restrictions. Okay? Now, I tried to sketch the graph of this function. Okay? So let me share that software. So I have this function here. So it's this guy here. Okay, y raised to 1 half log of e ln of x plus y minus 1. So the graph is something like this, and you will see there are some cut off. Okay, the x, the red guy here, this is your x axis. The green guy here, this is your y axis, and of course the blue guy here, this is your z axis. Okay, let me check. I think, yeah, that's the those are the axes. Those are the correct axes. But notice, what do we have in here? So we only take, so you see, y, the green axis here, it's just your y. It's your y-axis. And notice that there are no graphs on the negative side of y. Okay, on the negative side of y. So there's no graph on the negative side of y. And then if you look on the top, look at that. There's a space in between. Okay? There's a space in between there. Okay? So if you look at the top, there is some space in here. There's this guy here, this part here, you look, it looks like this is the line x plus y equals 1. And then there's a line in here. This space here gives you the line x plus y equals 2. Okay? So you see that there are some cut part. Okay? Okay? So at least our analysis for the domain is consistent with the graph of our function f. Questions? Okay. Let us write formally the domain. So here the domain of f, let me just write it here. The domain of f, this is of course the set of real numbers or the set of ordered pairs, okay? The Cartesian plane, so in R2, such that what? 1 less than x plus y, comma, x plus y not equal to 2, and you have your x or your y greater than or equal to 0. Okay, so the three conditions must be satisfied. Okay, all right. Let's go to our next problem here. Similar problem. Identify, sketch the domain of g of x, y, where this function here, g of x, y equals ln of y squared minus x minus 1 all over 4 minus x minus 1 squared minus y squared. So again, you have the ln function here. So this guy here should be greater than or, well, greater than 0. So solution here, we want y squared minus x minus 1 to be greater than 0. And then we got this denominator here. Of course, we don't want that to be 0. So we will have 4 minus quantity x minus 1 squared minus y squared. We don't want this to be 0. So let's see. First, let us sketch. Let us sketch y squared equals x plus 1. Okay, y squared equals x plus 1. And later, we will also sketch 4 equals quantity x minus 1 squared plus y squared. So this guy here, this is a parabola. This guy here, this is a circle. Okay? So let us look at the sketch now. So first, let's have the parabola. I think it's easier to sketch this parabola if we put the 1 in here on the other side, correct? On the other side of the equation. So let us rewrite this as y squared minus 1 equals x. So this is a parabola opening to the right. Okay. And then there's a shift of negative 1. Okay. It means it will shift to the left 1 unit. Correct? So suppose this is that negative 1. So we will have here, that's negative 1 at y equals 1 and negative 1, x will be equal to 0. So the graph will be somewhat like this. Okay? Okay? Let us increase. Let us increase the length of this parabola. It's somewhat like this, then like this. And then for this, we have a circle of radius 2 centered at 1, 0. So the other guy, we have, so this is at 1. Okay, this is the center of that circle. Radius is equal to 2. So we have that 2. Okay. And so this was 1 and this was -1. Let's look at 2 in here. Let's have -2 in here. So this is one of the points on the circle. This is another point on the circle. And of course, this is a point on the circle. And then that's 1, that's 2, that's 3 in here. This is another point on the circle. So this parabola here, the equation is x equals y squared minus 1. And then let's just sketch the circle. Okay, let's just sketch the circle here. So pretend that I have sketched the circle correctly. So this is your circle part. So x minus 1 squared plus y squared equals 4. Okay? So for the domain, we don't want the points on the circle not equal to 0 here. So we don't want the points on the circle. So for the domain, we will have, so let me just fix this part here. Okay. So for the domain, we have this part here. So we have a dashed part here. Okay. And then we need this inequality. We need this inequality. So again, if you just look at the parabola, there will be, it will be, the plane will be divided into two regions. The region which is eaten by the parabola, and of course the region, the other side of that parabola. So just like before, all we need to do is to use to get some points which will make our computations easy. Particularly, we can choose the point 0, 0. Okay. So we will have here at the point 0, 0, we have 0 squared minus 0 minus 1 greater than 0. So you will have -1 greater than 0. This is not true. Therefore, the point 0, 0 must not be a part, must not be inside the domain of G. The point 0, 0, it's in here. So it's inside the parabola. It's not included in the domain. So the domain must be the other side of the parabola, which means we have this region here. Okay. And then, of course, everything outside the circle as long as it is away from the parabola. So this is our domain. Okay. So formally, let us write again the domain of G. Domain of G, this is the set of all points x, y. This is in R2, such that you got x. So what do we have in here? X less than y squared minus 1, and that x minus 1 quantity squared plus y squared not equal to 4. So this is the domain of our function G. Okay. So again, I tried to sketch the graph of the function g. So let us look at this. So as you can see, you look at this. Okay. So if you look at the top view, this is the xy plane. Okay. The xy plane. So this is the y-axis, this is the x-axis. You can see the parabola somewhere here, and you look at this part here. Okay. There's some white part here tracing the circle. It's white because it's not included in the domain. Okay. Questions? So if you look at this down here, you will see that. Okay. So there is a question here. Sir, do we have to show the test case showing why the shaded region is the domain? Yes, it will help. It will actually help in your analysis. Just a single point, just evaluate a single point on your inequalities, etc. if you have the inequalities. So it will help you, it will remind you that the chosen point belongs to the domain, or the chosen point won't be in the domain, and therefore everything that uh, that is within the region of that point. Okay. Other questions? For our next problem here. Here we want to sketch the graph of h of xy equals 1 minus square root of 1 minus x squared minus y squared. So in here, in the previous two problems, we were asked to identify or sketch the graph of the domain. And take note that the previous functions, so this function g and then the function f, the variables are x and y. So the domain will be coming from the Cartesian plane, the xy plane. Okay. On the other hand, we are asked, in this problem, we are asked to sketch the graph of the function h. So the graph of a function having two variables will be a three-dimensional object. So in order to graph this, well, you just set your h to be the z, okay? So you will have here solution. You have here z equals 1 minus square root of 1 minus x squared minus y squared. So all you need to do is to manipulate this and try to rewrite the equation in a more familiar object or in a more familiar form. And you will see, you will have z minus 1 equals minus square root of 1 minus x squared minus y squared. If you square both sides, you will get z minus 1 squared equals 1 minus x squared minus y squared, and further manipulation or further simplification, we will have here x squared plus y squared plus z minus 1 squared equals 1. So this form here, we are familiar with this. This is an equation of a sphere of radius 1, okay, centered at the point 0, 0, 1. Okay, so this is a sphere of radius 1 centered at 0, 0, 1. On the other hand, our original original equation is this guy here. So we cannot get the whole sphere because the whole sphere won't give us a function. So in this form here, we will only get a hemisphere. We'll just have to identify which part where we need to get. Is it the upper hemisphere or the lower hemisphere? Notice this is minus here, okay? And therefore, what do we get? So we have, so let us try to sketch this three-dimensional space. So again, this is X now, this is Y, and then this is our Z. The center will be, what's the center? 0, 0, 1. So 0, 0, 1. The center will be at this point here. And then we have radius 1 because of this. Okay. So which side? Is it the upper hemisphere or the lower hemisphere? Is it the upper hemisphere or the lower hemisphere? So we get the lower hemisphere. Is that correct? We get the lower hemisphere. As you will see, if your X and Y are both 0, then you will have Z equals 1 minus 1 equals 0. So this is the center here. And the point 0, 0, 0, it's on this part. And that satisfies, this point 0, 0, 0 satisfies this equation. And this is below or lower than the center. Therefore, we get the lower hemisphere. Okay? So we just sketch this. So let me just try to sketch this. This is the parallel part. So this is one here. So this is one here. This is another one here. That's your one. So this guy here, and then we have this part, and then this part here. And then we have this. So let me just extend the hemisphere somewhere here. Okay. So pardon my sketch, but yeah, that should be that's the hemisphere. So I hope it's totally viewable, or it justifies at least the actual sketch of our function. So let me just sketch that in our graphing software. So let me show this here. So we have h of xy. This is 1 minus quantity x. Where was the function? So quantity 1 minus x squared minus y squared raised to 1 over 2. Okay? What happened there? I did not enter that. Repeat. So we have 1 minus 1, or quantity 1 minus x squared minus y squared raised to 1/2. Enter. Okay. So you look at that. That's our lower hemisphere. Okay. Questions? Okay. For our, so there's a question, sir, bakit po hindi siya buong sphere? Lower hemisphere lang. You look at this. If it were the whole sphere, then it will not become a function. The whole sphere cannot be the whole function. You have two values for the same x comma y. Okay? You have two values for the same x comma y. Just like if you have, so I'll try to put an analogy. In the two-dimensional case, you have your y equals square root of 1 minus x squared. And then the other guy, it's y equals minus square root of 1 minus x squared. If you both manipulate these two guys, if you rewrite this, you will end up with x squared plus y squared equals 1. But these two equations here, they represent different parts of your circle. The plus part, it's your y is positive. The minus part here, it's your y negative. Same is true with this equation. You look at this. We put this we put this one on the left-hand side, so we got z minus 1. And then this guy here, we have the square root thing. The principal square root, it's always positive, but we have a negative on this part here, which means the value of z minus 1 must be negative. Whatever you replace x and y with, as long as it's possible. So the value of z minus 1 must be negative. So it means it must be lower than z equals 1. That's why you have your z equals 1 in here. You only consider the values of z that are lower than 1. Okay? Does that clarify your confusions? Okay, other questions? So how would we differentiate for when we're supposed to draw 2D graph and 3D graphs? Good question. 2D graph. The 2D graph, it's because we are interested on the domain. Correct? You have a function. You have a function in two variables, which means what? The values of x and y are only considered. And therefore, you are only considering the two-dimensional plane. Okay? On the other hand, you have a function, say, in three variables. H of x, y, z. In the domain, you have to consider values for x, y, and z. X, y, and z in here. Therefore, if you want to sketch the domain of H, you need to consider the three axes: the x-axis, the y-axis, and the z-axis. That's just the domain. Now, what if we want to sketch the graph of the function itself? Remember, the graph of the function, h, in this case here, it will be z equals h of x, y. So now you have the three variables, the x, the y, and then this z in here. So the sketch of the graph of a function in two variables will be a three-dimensional object. Okay? The sketch of the graph of a function in two variables will be a three-dimensional object. The domain, take note, you only want the possible values of x and y. So you just have the two variables. So you only have the two-dimensional. In the three-dimensional, for the domain, you have the three variables x, y, z. I mean, in the function with three variables, for the domain, you have those three variables x, y, z. If you want to sketch the graph of this function here, you will have to put another variable, say w of h of w equals h of x, y, z. And now you have here four variables. Of course, we will not be asking you to sketch the graph of a function having three variables because it's a four-dimensional object. Okay? Other questions? So is it also because inside the square root part must be positive? Well, that's part of the condition in this square root thing. Okay? Of course, whatever inside the square root must be positive. But look at this. This negative here, it's outside the square root. This negative here, it's outside this square root, and there is no negative here. It means you are taking the positive side. Okay, for this circle here. Okay. So the value of y on this case, since we always get the principal square root, remember from your algebra classes, principal square root, it's always the positive. Okay. So the principal square root, it's positive. The coefficient here, it's positive 1. So the value of y must be positive. And then in here, you have the principal square root. It's positive, but there's negative here. It means that the value of y must be negative. Same is true with this guy, with these guys here. Okay? So being on the upper hemisphere or lower hemisphere does not depend on the value of the square root. The value of the thing inside the square root. It's always positive there. The value of the one inside the square root must always be greater than or equal to 0. What will give you the information whether you need to take the upper hemisphere or the lower hemisphere is the coefficient outside that square root thing. Is it minus or is it plus? Okay. All right. Other questions?
Sir, question po.
Sure.
Sa graph po ng two variables, lagi po bang half lang yung kinukuha sa magiging graph or may case po na yung buong graph yung need?
Well, if your function is defined for all the set of real numbers or for all the set of points on the plane, then you will take everything. For example, if I'm going to say your function h of x comma y, this is just x plus y minus 1. This is always defined for any values of x and any values of y. So in this case, we don't have any restriction. Therefore, we take the whole the whole xy plane. Okay? And does that answer your question?
Yes po, sir. Thank you po.
All right. On the other hand, maybe you have h of xy here, you have square root of x plus y minus 1. So this time we gave restriction. So we want x plus y minus 1 to be greater than 0. So we will only take half of that plane or portion of your xy plane. Okay. Let's have this last problem for this discussion. Identify the level curves of the graph of f of x equals sine inverse of x squared minus y squared plus 1 for k equals negative pi over 2, k equals 0, and then k equals pi over 2. And then we sketch a contour map for f using these level curves. So, oops, there is a typo error on this function here. It should be f of x comma y. Okay, so let me just replace this guy here. So let me, oops. So this should be f of x comma y. Okay. So for the level curves, it only means that the value of the function is equal to k. Correct? So for this, we have k equals negative pi over 2. So it means you have sine inverse of x squared minus y squared plus 1. This is equal to negative pi over 2. Or this means you have x squared minus y squared plus 1. This is equal to sine of negative pi over 2. And what is sine of negative pi over 2? That's negative 1. So this is equal to negative 1. Therefore, we'll have x squared minus y squared equals negative 2. Or we have y squared minus x squared equals 2. And remember, this is what? Hyperbola. Hyperbola. For k equals 0. For k equals 0. So same, you have sine inverse of x squared minus y squared plus 1 equals 0. So this means x squared minus y squared equals, or plus 1 equals 0. So this will give us y squared minus x squared equals 1. Again, this is a hyperbola. Okay? So another hyperbola here. And then finally, we have k equals pi over 2. So sine inverse x squared minus y squared equals, plus 1 here equals pi over 2. So we calculate, this is x squared minus y squared plus 1 equals sine pi over 2, which is equal to 1. This means you have x squared minus y squared equals 0. This is a degenerate case of hyperbola. So this is just actually two lines, intersecting lines. Intersecting lines. So intersect intersecting lines. So if we try to sketch this, okay, let me use different colors in here. I'll use red for the Cartesian plane. Let's see. We have here so this is your y, this is your x. Let me use black for the graph of this. Okay, y squared minus x squared equals 2. So in here we can rewrite this as y squared over square root of 2 quantity squared, or let me put 2 here, minus x squared over 2 here. This is equal to 1. So remember how you sketch hyperbola. Okay. So you will have some box. Okay. And then you consider square root of 2 because that's the denominator here. It's square root of 2 squared. This is also square root of 2 squared. So square root of 2, it's greater than 1. So suppose this is 1 here, this is 1 here, negative 1 here, negative 1 here. Square root of 2, it's roughly 1.414. So let's say we have this part here, this part here, this part here, and this part here. So you sketch the square or the rectangle. Okay. And then since here, the positive side, it's the y squared, your parabola, what's the orientation? The openings are up and down, correct? Okay. So you will have the parabola somewhat like this. Okay. So this is for your k equals pi over 2. So this is that. And then the other guy is this, again, this like this. Okay. This is for your k equals negative pi over 2. Now let me use blue for this guy here. We have the standard. So this is 1, 1, 1, 1, or 1, negative 1, negative 1, 1. And again, the positive part here, it's y. So same orientation as in the black guy here. But you will have the hyperbola that will look something like this. And then you will have something like this. Okay, so the blue guy, it's k equals 0. And then maybe let me use green for these two, for the x squared minus y squared equals 0. Okay, so in here, k equals pi over 2. This is the intersecting line with equations x equals y and x equals negative y. So the intersecting line will be this guy here. This is one of them, and then this is the other guy. Okay, so the green part, it's for the level curve, k equals pi over 2. Okay, questions? So that's my last problem. I hope you will able to, well, the solutions will help you answer your homework.